So far, we've learned how to add, subtract, multiply, and divide positive and negative numbers. Now these numbers that we've been working with are called integers. Integers are 0, 1, 2, 3, 4, 5 up forever, and negative 1, negative 2, negative 3, negative 4, negative 5 all the way down forever. And they're very, very important numbers, but there's other types of numbers that we need to be able to handle also. Probably the second most important type of number is the fractions. So we need to be able to review adding, subtracting, multiplying, dividing fractions. But in addition to these operations that the integers also had, there's one more operation we have to worry about with fractions, and it's reducing. It involves writing the fraction in its simplest form. For example, you could write the number 1/2, or you could write 7/14. 7 is half of 14. It's the same value. But we really want to take 7/14 and always write it as 1/2. It's the simplest form. By the way, there's going to be a simplest form for all kinds of things in math. You'll have a simplest form for square roots, for polynomials, for lots and lots of things. Pretty much everything has a simplest form, and it makes it easy to use that number. Like looking at 1/2 is easier than 7/14. Now, here's the bad news. Before we're able to work with simplifying fractions, we need to build one more skill. We need to understand prime numbers and how you can break a regular integer up into a product of primes. Fortunately, this isn't a really hard thing to do. So right now, we're going to work with prime numbers, learn how to factor integers into a product of prime, and then we'll be ready to start working on fractions. So here we go now. We need to start with understanding exactly what a prime number is and kind of what a definition of a prime number is so that we can think about it in the right way. So let's start with this thought. I'm going to write down 1, 2, 3, 4, 5, 6, 7, 8. You can go further if you'd like, but I'm going to work with just 1 through 8. And I'd like you to stop for a second and pause and circle every number that's a prime number. Okay, do that now. Next, I'd like you to do a second little chore, and that is, I'd like you to write down as best you can the definition for a prime number. And it's real important as we go through the process of learning that we kind of think about what we think is right and then read things, and then suddenly we understand it a little deeper and better. But if we don't bring up our thoughts first, it doesn't help us out quite so much. So take for a moment and just write down as best you can the definition of what a prime number is. And if you get really stuck, just hit play again. So hit pause now. Okay, so in the world of the definition here, a prime number is technically, and by the way, I realize that not a lot of people are going to get this right, and that's okay. Prime number is any whole number that's greater than 1, whose only divisors are 1 and itself. So the only numbers that go into it evenly are the numbers 1 and whatever itself is. So for example, a prime number would be 13. 13 is a prime number because the only things that divide evenly into 13 are 1 and 13. On the other hand, 14 isn't a prime number because not only does 1 and 14 go into it, but 2 goes into it evenly and 7 goes into it evenly. Okay, so let me have you just take a moment and look at your list of what you circled between 1 and 8 and see if you want to change anything. And then we're going to go through that list and talk about which numbers are prime numbers and which aren't. So hit pause again and do that real quickly. All right, so let's start with this list. First question is 1 a prime? And the answer is, well, in the definition it says it has to be bigger than 1, not greater than or equal to, just greater than 1. And since 1 isn't greater than 1, 1 can't be a prime. Next, is 2 a prime? Now this is the one that's a little bit tricky because does 2 fit the definition? Is it bigger than 1? Yes. Are the only numbers that go into it 1 and itself? Yeah. And so 2 is in fact a prime number. Now what's interesting is if 2 is a prime number, what numbers can't be primes? Well, the numbers that can't be primes is any number that 2 goes into. So for example, 4 can't be a prime. or 6 or 8 or 10 or 12 or 14 or 16. All the even numbers greater than 2 can't be primes because 2 would go into them. And then that number, for example, if you just pick the number 40, well, not only can 1 go into it in 40, but 2 can go into it also, so it isn't a prime. All right, so 2 is a prime, and it's the only even number that's a prime. Next, is 3 a prime? Well, yeah, 3 is a prime, because the only numbers that go into 3 are 1 and 3. Is 4 a prime? Well, 4 is an even. 2 goes into it, so it's not a prime. Is 5 a prime? Yeah, because only 1 and 5 go into 5. How about 6? No, in fact, we don't even need to talk about the even numbers anymore. Let's just not worry about those. Is 7 a prime? Yeah, 7's a prime. And 8, because it's even, isn't a prime. Now, we've got those first 8. What we're going to do now is we're going to take a moment and just write down a list of primes and go up a little ways. And so, we've got 2, 3, 5, and 7 so far that are primes. Let's keep working our way up. 9. Well, 9 fails because 3 goes into it. How about 11? Yeah, 11, nothing goes into 11 but 1 in itself. 13. Yeah, nothing goes into 13 but 1 and itself. 15. Well, 15, you know, that's kind of like the even numbers. If you've got 5 as a prime, every number that ends in 0 or 5 can't be a prime. So 15 can't be, 25, 35, 45, they're all out, they can't be primes. So really, we only need to look for the numbers that end in 1s and 3s and 7s and 9s. And so let's go up that list. Let's see, we already have 11 and 13 are primes. How about 17? Yeah, that's a prime. 19, yeah, no numbers but 1 and 19 go into 19, that's a prime. 21, oh no, 21, we've got 3 and 7 go into 21, so that's not a prime. 23, yeah, that's a prime, nothing goes into 23 but 1 in itself. 27, oh, 27's 3 times 9, so that's not a prime. 29, yeah, that one works. That one's a prime. 31, that's a prime. 33, well, that's not because 11 goes into it. 3 and 11. 37, yeah, that's a prime. 39, 3 times 13, nope. I'm going to go just a little further. 41, now that's a prime number. 41's a prime. 43, that's a prime. 47, yeah, there's none of the times tables that go into 47, so 47's a prime. 49 is 7 times 7. That one isn't. And now we get to the one that I want you to think about for a moment. Is 51 a prime number or not? So the question is 51 a prime? At this point, we need to go back and look at how we divide numbers and how we decide what's a prime for just a couple of very special numbers. For example, we already talked about the fact that anything that is a multiple of 2, all the even numbers from that point on are not primes. And so any number except for 2 that ends in 0, 2, 4, 6, or 8, not primes. And we spoke for a few moments about the number 5. Any numbers that end in 5 or 0 are not primes. Okay? But is there anything else that we know? Is there any other special way of knowing, for example, how to know whether or not something is divisible by 3? That would be nice. And in fact, there is a way to know whether something is divisible by 3. And here's what it is. It's a little bit strange. But it is that if you add up all the digits in a number, for example, 156. If you add up the digits, 1 plus 5 plus 6. So 1 plus 5 is 6, 6 plus 6 is 12. And if that sum, the 12, is divisible by 3, then the original number is divisible by 3. Now, that's a fact. In fact, if you go to many math teachers, they can actually show you the little mathematical proof. It's a little complicated, but they can show you that that has to always happen. It can never not work. And so, 156 can be divided by 3. Okay? Now, let's just kind of check a couple numbers and ask, can this be divided by 3? Then we're going to work our way back to the number 51. 123. Is 123 divisible by 3? You can hit pause and work on it for a second, if you'd like. Every time that we talk about a little problem, please go ahead and hit pause, work on it for a second, then come back and we'll talk about it together. 123 is 1 plus 2 plus 3, which adds up to 6. 3 goes into 6, and so 123 is divisible by 3. What about the number 187? 1 plus 8 is 9. 9 plus 7 is 16. No, 187 is not divisible by 3. Okay, that doesn't mean it's... I don't know whether it's a prime yet. I just know that 3 doesn't go into it. How about 1,437? Well, 1 plus 4 is 5. 5 plus 3 is 8. 8 plus 7 is 15. 3 goes into 1,437. Okay. Last one, 6,543. Well, 6 plus 5 is 11, plus 4 is 15, plus 3 is 18, and so 3 goes into that big number. And so now we come back to the question, tell me about the number 51. Well, 5 plus 1 is 6. So 3 goes into 51. In fact, 3 goes into it 17 times. Okay, now we're not going to write up primes forever. We're going to stop at 51, but there's a large part of math, just kind of an interesting thought, that is involved in understanding primes, and very, very large primes. In fact, for a long time in the world, the most top secret codes were based on 100-digit primes. And mathematicians and scientists would have to figure out whether or not this 100-digit long number was actually a prime number. And they would use it to send codes from submarines to land and all kinds of things. It's kind of an interesting study. And if you ever get to upper division math and you take a class in number theory, you'll hopefully get to see how they did that. But prime numbers are very important in lots of things that happen in the world today.